Have you ever looked up at the night sky on a clear, dark night, far away from the city lights, and gazing at the seemingly infinite expanse above, wondered how long it will all last? How long will those stars continue to shine? For as long as we've been stargazers, from ancient civilizations to modern-day astronomers, humans have asked this fundamental question. We know, with increasing certainty, that the universe had a beginning, the Big Bang, the cataclysmic event that birthed everything we know. That occurred approximately 13.8 billion years ago, a truly unfathomable stretch of time. But what about its end? What is the ultimate fate of this vast cosmos? For decades, based on the best available evidence, scientists thought the universe would continue to expand forever, driven by the mysterious force of dark energy, gradually fading into an infinite cold and dark emptiness. But recent, groundbreaking new discoveries suggest a potentially very different story, that the universe might not be on a one-way trip to oblivion, but rather on a cosmic round trip, a cyclical process, not a one-way journey into eternal expansion. Recent research hints that we could, in fact, be almost halfway through the universe's current life cycle, and that a slow, gentle, but ultimately inevitable collapse could begin in a mere, cosmically speaking, 65 million years. In cosmic terms, that's the blink of an eye, a fleeting moment, about as long ago as the dinosaurs disappeared from the face of the Earth, marking a significant turning point in our planet's history. This new, potentially revolutionary timeline brings the universe's ultimate fate much closer to home, making it feel more immediate and relevant, sparking immense excitement and understandably intense debate among scientists across the globe. It's a dramatic shift in perspective, like finding out that the ending of your favorite story is not a distant possibility, but just around the corner, ready to unfold. Science is, after all, always evolving, constantly refining its understanding of the cosmos, and every new discovery, every new piece of evidence, adds another twist and turn to our ever-unfolding cosmic story. This isn't a reason to fear the future, but a compelling reason to look up at the stars with fresh curiosity and a renewed sense of wonder and awe. To understand the universe's end, we have to start at the beginning. The Big Bang wasn't an explosion in space, it was the birth of space itself, expanding from a point smaller than an atom. Everything we see today is a product of that expansion. But what is the universe made of? Surprisingly, all the stars, planets, and dust make up less than 5% of it. About 27% is dark matter, an invisible framework holding galaxies together. The remaining 68% is dark energy, a mysterious force pushing the universe apart. Dark energy acts like anti-gravity, causing the universe's expansion to speed up. The fate of the universe depends on the battle between gravity and dark energy. For years, dark energy seemed destined to win, ensuring endless expansion. But new research suggests dark energy might not be constant after all. If it changes, so could the universe's fate. The cosmic story is far from settled. Let's dive deeper into the expanding universe. In the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us, the first real evidence for the Big Bang. Imagine the universe as a loaf of raisin bread rising. Every raisin moves away from the others as the dough expands. Scientists once thought gravity would slow this expansion, maybe even reverse it. But in the late 1990s, astronomers found the expansion was accelerating, not slowing. This shocking discovery pointed to a mysterious force, dark energy, overpowering gravity. The leading idea is that dark energy is a property of space itself, called the cosmological constant. As space expands, more dark energy appears, fueling even faster expansion. This feedback loop predicts a cold, empty future, the Big Freeze. But what if dark energy isn't constant? That's where new theories come in. For decades, the idea of a constant dark energy, uniformly distributed throughout the cosmos, has profoundly shaped our understanding and view of the universe. It's been a cornerstone of cosmological models, influencing how we interpret everything from galaxy formation to the large-scale structure of space itself. But what if that cornerstone is flawed? What if it's not constant as we've long assumed? A compelling new theory challenges this notion, suggesting that dark energy isn't a fixed entity, but rather a dynamic field, often referred to as quintessence. A field that possesses the intriguing ability to fade and weaken over vast stretches of time. Imagine dark energy as the fuel in a car, steadily running out of gas. For billions upon billions of years, It's been the primary force fueling the universe's relentless expansion, pushing galaxies further and further apart. But now, according to this theory, the tank is beginning to run dangerously low, its reserves dwindling. As this quintessence field gradually weakens and its influence diminishes, the relentless pull of gravity, the force that binds all matter together, could eventually take over, effectively halting the universe's ongoing expansion in its tracks. And if dark energy continues to fade, gravity might not just halt expansion, but eventually begin reversing it, pulling everything back together. The universe, after eons of outward growth, would reach a standstill, its expansion grinding to a halt. Then, imperceptibly at first, it would slowly, inexorably begin to contract, drawing everything closer together. Distant galaxies, once receding at ever-increasing speeds, would begin to drift closer to one another, their paths converging. This would mark the beginning of a slow, agonizing cosmic collapse, a reversal of the Big Bang itself. This isn't merely abstract speculation or a far-fetched hypothetical scenario. It could potentially provide elegant solutions to some of the deepest, most perplexing puzzles in the field of physics, offering a compelling explanation for why dark energy's observed value is so incredibly small, a question that has baffled scientists for years. Interestingly, the scientists who initially developed this theory weren't specifically aiming to predict the ultimate fate or the end of the universe. Instead, this potential cosmic collapse emerged as a surprising and unexpected result of their complex calculations and theoretical explorations. It highlights the fascinating nature of scientific inquiry, where sometimes solving one seemingly isolated mystery inevitably leads to the unveiling of an even bigger, more profound, and ultimately more challenging one. So, if dark energy does indeed fade and weaken over time, then our understanding of cosmic destiny and the ultimate fate of the universe could be radically, profoundly different from what we currently believe. The grand narrative of the universe, the story of everything, might be heading for an unexpected and dramatic plot twist. And ultimately, it all hinges on unraveling the true nature and behavior of this mysterious, enigmatic force we call dark energy. What could fading dark energy be made of? The new model points to a hypothetical field linked to a particle called the axion. Axions are lightweight, elusive particles that might also make up dark matter. This theory connects two cosmic mysteries, dark matter and dark energy, into one elegant idea. Picture the universe as a trampoline. In the standard model, dark energy is a constant push. In the axion model, it's a fading vibration. Over time, this vibration loses energy, like a bell's ring fading away. For most of cosmic history, this fading field would look just like constant dark energy. Only recently would its effects start to differ, subtle but detectable. This model feels more natural than a constant energy, offering a physical explanation for dark energy's behavior. It suggests cosmic acceleration is just a temporary phase, not the universe's final state. The universe's fate may be more dynamic than we ever imagined. How did scientists come up with this radical idea? It took decades of data from many sources. By observing distant galaxies, astronomers look back in time, mapping the universe's expansion history. The Cosmic Microwave Background, CMB, gives us a snapshot of the early universe. Galaxy surveys like the Dark Energy Survey and Sloan Digital Sky Survey chart millions of galaxies, measuring how space has stretched over billions of years. The Princeton team didn't collect new data. They reanalyzed existing data with a new question. Does a fading dark energy model fit as well as the standard one? Their axion quintessence model matched the data beautifully, even resolving some tensions between datasets. This means a future big crunch isn't just speculation. It's consistent with our best current knowledge. The universe's fate is written in the light of ancient stars and galaxies. By reading this cosmic history, we glimpse possible futures. The story is still unfolding. For years, the universe's fate seemed a choice between two starkly different endings, a cosmic fork in the road with only two paths forward. These weren't just theories, they were the dominant narratives shaping our understanding of existence itself, the big freeze or the big crunch. Each presented a dramatically different vision of what awaits us in the far, far future. The big freeze predicts endless expansion, a scenario where the universe continues to stretch and thin out indefinitely. Galaxies drifting apart, stars burning out, and a cold, empty universe devoid of energy and life. A truly desolate and lonely fate. The Big Crunch, on the other hand, envisions expansion halting, then reversing, pulled back by the relentless force of gravity. With everything collapsing into a hot, dense singularity, a mirror image of the Big Bang, but in reverse, a fiery and chaotic end. But now, the new theory offers a third path, a surprising twist in the cosmic tale. A slow, gentle collapse driven by fading dark energy, the mysterious force that's been accelerating the universe's expansion. Instead of a violent implosion, a cataclysmic crunch, this new scenario paints a picture of gradual decline. The universe would contract gradually over billions of years, a slow and stately waltz towards oblivion. It's a more measured end, a cosmic sigh rather than a scream, but still leads to a final singularity, a point of infinite density. Comparing these futures is fascinating, each offering a unique perspective on the ultimate fate of everything. Infinite emptiness, the chilling prospect of the big freeze, fiery collapse, the dramatic conclusion of the big crunch, or a slow return to the beginning, the gentle fade into a final singularity. This new model suggests we might be closer to the end than we thought, that the universe's clock is ticking faster than we previously imagined, cosmically speaking. It changes our perspective, forcing us to reconsider our place in the grand scheme of things. Maybe we're in the late afternoon of the universe, not the early morning, the golden hour before the long night. Our daily lives go on, seemingly untouched by these cosmic considerations. But our place in the cosmic story feels different, imbued with a sense of urgency and wonder. The universe's ending is no longer an abstract, distant event relegated to the realm of theoretical physics. It's a chapter that could be closer than we ever imagined, a page turn that might be just around the corner. Remember, this new theory is just that, a theory. Science is about building models, testing them, and refining our ideas. Both the standard model and the new fading dark energy model fit current data. We're at a thrilling crossroads in cosmology. Next-generation observatories like the Vera Rubin Observatory and the Roman Space Telescope will map the universe in unprecedented detail. These tools could finally reveal if dark energy is constant or changing. The possibility that our cosmic destiny might be different is not a crisis. It's an opportunity. Uncertainty drives discovery, pushing us to look closer and think deeper. Whether the universe ends in a freeze or a crunch, the quest to find out is one of humanity's greatest adventures. The story isn't over. The next chapter is waiting to be written. A new potential death date for the universe collapse could begin in just 65 million years. It's a number that feels both distant and startlingly close. The universe is not a static backdrop. It's a dynamic story, and we're lucky to witness a part of it. Discoveries like this change more than textbooks. They change our perspective. Knowing the cosmos might have a finite lifespan makes it feel more precious. We are tiny beings, but we can understand the universe's grandest secrets. Let these cosmic timescales inspire your curiosity. Go outside, look up, and think about the universe's incredible journey. The search for answers connects us to something much larger than ourselves.